Hello and welcome to the Sub 1 YouTube channel. My name is Ray, and in this video, Fred's left hand part 9, we're going to set up the bicep in order to power the forearm. So I've got a PCA 9685 located in the forearm. Those who have followed the series along so far will have seen that being installed. They look very much like these, and it'll be driving servos which are rated around the 6-volt mark. It'll also drive this servo which is also rated around the 6-volt mark, and Fred's power supply is 20 volt, so we need to drop that voltage down. Now there's nowhere in the bicep itself that I can fit this 20 amp switch mode power supply, which is a DC-DC converter, and will drop that voltage from 20 volts down to 6 volts efficiently. So in order to overcome that, we're going to mount this on the back side of the arm on the outside, attaching to the framework. To make it easier to work on, I have removed this from Fred, disconnecting it at this component. So this is actually a duplicate component that's installed on a Fred. It has a ball bearing race in here and gets pulled on, and there is another video, I'll try and put a link in the description to it, on building Fred's left shoulder. So with this duplicate part we can assemble the bicep onto that. Now when you're looking at this framework, I've already got the covers on. This side is the back side, this is the front side, and on this part, if you've got the correct version, it actually does say front, just up in here. It's embossed into the actual part, so we know that this goes on in this direction, and that slides in quite easily. If you are finding you can't get these parts to slide in nice and easy, then you probably have your settings not quite set right. In that case, you probably want to print out the calibration parts. So these are the calibration parts. If you go to the Inmoov website and go to the Build Yours tutorial set, at the top of each of the tutorials you'll actually find a link to these calibrator parts. If you can't get these to just slide together straight off the printer and be a little bit firm, then you may have to adjust some of your settings. Different things associated with this can be over extrusion, so check your extrusion is correct. If you tell it to extrude 100 millimeters of material, then only 100 millimeters should go through. If you get more go through, it'll cause over extrusion and the parts will be too fat and they won't fit in. The other one that will cause issues is horizontal expansion, and we're actually finding a number in the order of -0.15 is a very common correction value. You may have to go up or down from there depending on if it becomes too loose or is still too tight. So with that bit covered, we're going to assemble this arm back together. I'm going to screw this in to begin with. I have actually printed out and assembled this in a previous video and attached it to his arm, so I'm not going to go into too much detail on building this. This then just clips on. Now I've also printed out a spare of these. This is the elbow shaft gear, and it slips on like so. It's the same as the one mounted on the forearm. Grab the bolt, and when you print these out, you may find it's a little bit on the tight side. Just run an 8mm drill down and your hinge bolt will go in quite easily. and I forgot to put a part in. So this part it's in there. Now, the servo is a modified servo. So we start out with a high-tech HS805BB or equivalent. This is one of the giant-sized servos. I've removed the potentiometer out of it and extended the wires out. I think from memory I used 300mm length of wire. And in the case of the lead, I think initially I replaced the lead on it, but I've made another one. This one's about 250mm long with the standard RC servo type plug on the end. And then I made an extension that goes from there all the way back to the PCA 9685. And that was about another 300mm long. Now you can buy these things, these extensions readily off eBay. I made my own because I wanted to use a heavier wire because it is a larger servo. For that you will need a good set of pliers to crimp those up. I've made up plenty of these crimps on my channel in the past, so even going back into where I made all this up, go and have a look at those if you need to see how I did those. We're going to just slide that back into here, the right way around. And that will get connected up onto there. Now, I'm not actually going to connect it just yet because I haven't installed the servo, I haven't installed this joint, and that is important. If this thing tries to move and this joint isn't following along, it will just keep moving and it will do some damage. So let's rotate this round on the other side so you can see where everything goes. So this will come down to the back of this plate. This is the pot and it would connect down into here. There is a slot for it and it fits in quite nicely. Now this one does stand out a little bit when it's all set up, so I will have to hot melt glue it into place to hold it. There is this gear which connects onto it, and this then drives the gear. This part then clips onto there and holds it all in place. Now there was provision for a hole through, or there is a hole through here, but it doesn't actually line up with the matching hole in there. So I may have to elongate that hole, and I'll probably end up putting one of these knurled nutserts in so that I can take it on and off with those. Okay, to mount this up, I created this part and I'll put a link in the description to the STL file for it. The idea behind this part is this will mount on it, and I can use these short screws and screw those into the hole there. And then this will sit on here, and what we need to do is drill some holes, put some nutserts in so that these screws can go through. Now these screws holding this onto my adapter plate are 6mm long M3s, and these ones are 12mm long M3s. Sorry, 10mm long M3s. So before I mount this onto here, we really need to mount it onto here first. So when you're happy with your positioning, there is a flat spot runs along here, and then it bends and turns over here. I'm going to go with this area. It helps keep all the wires contained in the back. We can mark where our holes are going to be. And using a 3mm drill, we'll drill it out. Okay, so that's got our power supply wired up. Now our wires will come down through the middle here, and you can't see Fred in the camera, so I'll have to bring up another photo later. And the wires will come out through here. With those wires, we need to break out our positive and negative wires like we did on the ones going into the forearm, and they will connect into the in terminals here. The I2C wires will continue on through, and we will need to put in another plug for these wires to plug into. We then take the wires from these two and hook them in, same to match up with these as well. And that gives us all of the power we need. Having this as a plug there and as a plug here means that we can take the forearm off the robot and unplug it if we ever need to do service work on the hand. And then if you need to, you can then create an extension lead to plug from here to here. And I have plenty of cable that I can do that with. I think I initially bought 5 meters of this stuff, and I've used it in other parts of the robot already, like the shoulders. Alright, so if we want to be able to remove this off like I have now in the future, we probably need to make it a plug here. So we'll need to use some of this excess that I've got to make up this short piece in here. I'm going to cut off around 200 millimeters. Now the first 3 wires on each end are our power wires. And in this case, I'm going to use this side as my power. So to make sure we don't get confused and wire it back to front, I am going to get a highlighter and mark that. Start with the power wires. Always pays to give it a good tug after you've put the connector on, just in case it didn't grab properly, like that one. Okay, so that's a wiring loom. This is my little test loom here that I can plug into my little Raspberry Pi 3. These wires I can connect up to my power supply, which I will do now. Now, before we connect the arm in, or the forearm onto this plug, we need to make sure we set the voltage output on the switch mode power supply. Now, by default, these things come shipped set at 12 volt DC, which is a little bit high for our servos, which is what that one supplies. Our servos rated at about 6 volt. So I'm going to set my power supply up to 20 volt, which is what I'm planning on running at. Okay, so that's on. Next trick is to set the power switch to on. So we now have a light, and I need to go. So we've got a multimeter set to volts DC, and we can go onto these terminals here, and the output voltage is actually set at 16.7 volts. So that's there's two outputs here, or two pots here. This one is listed as CV, or constant voltage, and this one is CC, constant current. Now, the major difference between the two is the CC will prevent the current from exceeding that set amount that you set it at. By default, they're usually wound up to full bore. And in this case, I want to wind our voltage. I'm going to move this up so my arm doesn't get in the way. And that's coming down. Six volts. So our input power is near enough 20 volts, 19.93, and our output voltage 6.01. So when I connect this up to the hand or the forearm, I won't overpower and blow it apart. This also stabilizes the two side arm sections here, so it doesn't come apart. I will have to undo two of these screws in order to mount it back onto thread. And I just need to put in a plug like this one on the end of the cable for thread. Well, that'll do for this video. If you like these videos, don't forget to click on like, subscribe, ring that notification bell. It's a form of support that helps the channel a great deal and costs you absolutely nothing. If you'd like to support the channel further, by all means join my Patreons Go Lucky and Lorenz Berger, both VIPs, and my builder Elmrails45 in supporting the channel. It allows me to get components like these to show you what's going on. Fred is also online, and you can have a chat to him in Discord. There is a link in the description below. You can join the growing community down there as well. If you've got any questions, by all means ask them there, and I will do my best to answer them. And we'll see you in the next video.